Alright, in this video I'm going to be going over the basics of threading in Java, and I'm going to talk a little bit about what threading is, some of the things you might use it for, and then some of the dangers that come along with using threading. But to begin with, normally when we call a function, we would call that function by name. We expect the function to go up there and do whatever it does, and then return to the place we called it. So if I call fun1 and then I call fun2, I would expect those to execute in that order. I would not expect fun2 to execute until fun1 had returned. And that's exactly what we get here. With threading, we're going to be allowed to break this function or any function really away from the main program and let it run independently. And so if this function were on its own thread, we would call it, it would come up here and start doing whatever it does, but then main would continue on with the next line of the program and would not wait for fun1 to finish. And so it allows you to use more of the CPU. Modern CPUs have multiple threads, multiple cores, and if you want to take advantage of that, you need to have some understanding of threading. Not all applications should be threaded. The threading process can be hurtful to a program if you don't know what you're doing, or if that program doesn't need threads. If the program is not structured for threading, then this is not something you want to do. But some of the places you would see threading is in like video games. Some games will have a thread running the main engine. You may have a thread running the graphics engine. You may have other threads running the physics or the AI. Sometimes you'll have a thread loading assets or unloading assets and things like that. And so if the program can be broken up that way, you can use threading to gain a lot of performance. Another place we're going to use threading in our lab is in sorting. A sorting algorithm, if you had a lot of numbers, several thousand numbers that you needed sorted, it can be beneficial to split those numbers up into multiple lists, have each list sorted, and then merge those back together. And it can actually increase your time or decrease your sorting time by quite a bit. So let's look at we're going to look at two different methods of threading in Java. The first one is going to be using the thread class. So I'm going to create a class. I'm going to call it demo1, and it will extend thread. And if we're going to extend thread, we're going to be required to provide a public void run function. And run is the function that is going to run on its own independent thread. We'll also include an integer up here. I'll just call it n to keep track of which thread this is. Inside this run function, I'm just going to use a for loop to count to 10. So and this will count, actually it will count from 0 to 9. Now to use this class, I'm going to create an object. My class is called demo1. So I will say demo1. I'll just call it t1 equals new demo1. And then to call run, I'm not going to type t1.run. I'm going to type t1.start. And start is going to create a new thread, and then it will execute run on that thread. So t1.start. If you just call run, if you just say t1.run, you do not get another thread. It will be the same as any other function. But if you call start, you do get another thread, and it works just fine. So there we go. N equals 0 there. because I didn't initialize it, and we get 0 through 9. All right, so I'm going to modify my class a little bit so I can set in. I'm going to put a constructor in here. That way I can set in to whatever number I want to pass in. And then when I create my demo here, I'm going to pass in a 1. And then we see N1 counting from 0 to 9 as expected. But now let's create a second object from the demo class. I'll call this one T2. And I will pass in a 2. And then I will call T2.start. And here we can see, and your output may be a little different from mine, but we can see that N1 runs and then N2 runs. And in some cases, N1 may run for several numbers and then N2 step in and get a few numbers in. And these two threads are fighting back and forth over the console here. Your output may be totally different than mine. A lot of this depends on your operating system. It also depends on your hardware. If you're running an AMD CPU or an Intel CPU, I've seen differences just based on the hardware. But there you have it. T1 calls start, and it does its thing, and then main immediately calls T2 start, and it also starts doing its thing. And so there's an example of two different threads running at the exact same time. This is one way. You fill out whatever you want your thread to do in the run method there. There's another way of doing this. I'm going to create another class called demo2. And instead of extending thread, I'm going to implement Runnable. And it's going to put the name of my class in red because I have not overloaded or overridden the run method. But we'll take care of that in a minute. I'm going to put in a constructor here. I'm going to have the same int to show which thread I'm on, and then a similar constructor, demo2. And then we will override run. So public void run. And you can put your annotation up here if you want to. There we go. And I'm going to copy my for loop from up above. Paste that in there. And you can format this guy to keep it looking good. And this will effectively do the same thing, but the approach is slightly different. To use this class, I'm going to create an object from demo2. I'll pass in a 3, and then I will create a thread. I'll call this T3 equals new thread, and I will pass in my object from demo2. And then I will call T3.start, and this is how you would approach this if you choose to implement Runnable rather than extend the thread class. Both are viable options. It depends on what you're doing as to which one would work best for you. So let's run that. And down here we see T3 takes off first, then T2, then T1. Notice we called T1 first, but thread 2 actually got to the processor first. But there's 3 different threads, and technically this is actually 4 threads because we still have our main thread here going. So 4 different threads all running at the exact same time. One other approach to implementing Runnable, you can start the thread in the constructor itself. So if you wanted to do that, it would look like this. We'll take this out. I will come up here to my class and I will add a thread. And inside my constructor here, I can say t equals new thread, and I will pass it this. Remember, this is a reference to the current object. And then I will call t.start. And this will effectively do the same thing. So when we create the demo to object, the constructor will execute and it will create the thread automatically, immediately. So now we run the program. We'll get similar results. It's just a different way of approaching it. All right, this video only touches on the very basics of threading. There's entire books and classes put together to cover all the caveats that come with threading. Some of the basic things you need to know are, when working with threading, it is okay for multiple threads to read the same memory at the same time. Just like multiple people can read the same literature at the same time. However, it is not okay for a program to be writing to a memory block while another thread is trying to read that memory block. And it is certainly not okay for multiple threads to be writing to the same memory at the same time. So a lot of the work that goes into threading is planning and structuring your program so that the threading is actually beneficial to it.